In this video, we are going to understand the different types of quadrilateral. Well, the first definition that comes to our mind that when we talk about a quadrilateral is it's a four-sided closed figure, right? It's a four-sided closed figure, and what else we know that here the sum of all four angles of this quadrilateral is 360 degree, right? The sum is 360 degree. Now let's do some modification with this quadrilateral, like the same quadrilateral. If I make some changes over here, this time what I'm going to do is to draw a pair of its sides as parallel. So I draw this pair. Now, still it qualified to be called as a quadrilateral as it has a four-sided closed figure, but we have some characteristics. Special characteristic here is that here one pair of opposite side, that is AB and CD, as you can see, it's parallel. So now we can say that it is a special type of quadrilateral, right? With one pair of opposite sides, sorry, this one is parallel. And then we call this as a trapezium. Now this figure become a trapezium. So what is that? Its characteristics, it will retain the properties of a quadrilateral that here too also all sum of all angles will be 360 degree, but what's that special? As you can see here that these two lines are parallel and here AD, considering AD to be a transversal, using the co-interior angle property, we can say that sum of these two angles, that is angle A plus angle D, should be how much? 180 degree. And so will be for these two. That is angle B plus angle C should also be equal to 180 degree. And that's the main characteristics of a trapezium. But sometimes these non-parallel sides can be equal. In that case, we say it's an isosceles trapezium. But only when it is mentioned that these are the non-parallel sides are equal, then we say it's an isosceles trapezium. Now, continuing with this, if I do some more modification on this quadrilateral or say trapezium, what I'm going to do here is to make both pair of opposite sides as parallel. Let's say if I draw another quadrilateral, this time I'll make both pair as parallel. Or I should, yeah, I'll just draw it. Okay, what you can figure out here that in this quadrilateral, it still retain every properties that a quadrilateral has, but the difference here is that, or we can say the characteristics that it has emerged into this is number one, here not only one pair, but both pair, right? Here both pair of opposite sides are parallel. That means AB is parallel to CD and AD is parallel to BC. So we can say that now using this property that adjacent angles, I mean to say that these two angles should be supplementary, reason being these two AB and CD are parallel and here AD is acting as a transversal. Keeping this in mind, I can say that angle A plus angle B is 90 degree. A plus D is 90 degree. D plus C will be 90 degree. For the same reason, here these two are parallel. So now we can say that using this characteristic that opposite sides are parallel, we can say that adjacent angles are supplementary. That is angle A plus B will be equal to 180 degree. So will be angle B plus angle C. B plus angle C is 180 degree and angle C plus angle D is equal to 180 degree. It has several other characteristics. Let's do one by one. So first thing that we get to know here is that here adjacent angles are supplementary. Coming back to the definition, we know it's a quadrilateral where two pairs of opposite sides are parallel. And other characteristics is number one, we can say that adjacent angles are supplementary. Number two, opposite angles are equal. So angle A is equal to angle C and angle B is equal to angle D. And further, we can also say that here the diagonals, these are the diagonals. Well, you know what are diagonals? Line joining the opposite vertex are called the diagonals. So the diagonals bisect each other. Let me show you what I mean to say here. If I draw two diagonals here, I join AC and BD. So if I join this, say this is the point of intersection. In that case, AO is equal to OC and OB is equal to OD. That's what it means to say that diagonals bisect each other. So this is the other characteristics of parallelogram. So let's sum up here. Opposite sides are parallel and opposite sides are equal. How can we forget? AB is also equal to CD and AD is equal to BC, right? So this is the characteristics. So if I write down all the characteristics of parallelogram, these are the characteristics. We can say these are the properties here. Here, both pair of opposite sides are parallel and they are equal also. That is AB equals CD and AB parallel CD. And both pair of opposite angles are equal. That is angle A is equal to angle C and angle D is equal to angle B. The third one is that diagonals bisect each other. The diagonals bisect each other. That is AC and BD will bisect each other. In short, we can say that AO is equal to OC and OB is equal to OD. And lastly, adjacent angles are supplementary. That is angle A plus angle B 180 and angle B plus angle C is 180. Now we'll do special type of parallelogram. One is rectangle and the other is a rhombus. There is one more, that's square, that we'll study later. So let's begin with these two first. Now I say this is a special type of parallelogram. Rectangle is a special type of parallelogram. So definitely besides it is a special type of parallelogram means it will have all the characteristics of a parallelogram plus something in addition. So what is it? What is that additional properties that this rectangle will have? Well, one more time, it will have all the characteristics of parallelogram. Here, opposite sides will be equal, opposite sides will be parallel, diagonals bisect each other, and every other characteristics that this parallelogram have. Now, what is a special, right? As I said, it's a special type of parallelogram. The characteristics that it special have here that each angle is 90 degree, right? And further, we can add on that here the diagonals are not only bisect each other, well, it should bisect each other, but they are equal in length. That means here the length of AC will be equal to BD. AC is equal to BD. These are the two additional characteristics this parallelogram, special type of parallelogram that is rectangle have. Now moving to rectangle, if I name this figure, let's say as ABCD again. Now, since it is a special type of parallelogram, it will have all the characteristics, all the features, properties of parallelogram. In addition to this, the other characteristics that this have is number one, here all sides are equal in length and the diagonals bisect each other at 90 degrees. So bisect each other has to be there because it is a type of parallelogram. But here the diagonals not only bisect each other, but bisect each other at 90 degrees. That means AC will be perpendicular to BD. Right. So now we can move to the next type of quadrilateral, or we can say special type of parallelogram, that is a square. Right. Let's shorten it. Now, as you know that square is a special type of parallelogram. So what is that special characteristics? So whatever the characteristics you had on rectangle and that rhombus, if you club together, it becomes a square. That means like rectangle here, each angle will be 90°. And like rectangle, here the length of the diagonals will be equal. That means these two diagonals will be equal in length, right? So it takes two characteristics, two special characteristics from rectangle. The first one is that each angle is 90°, and the second, the length of the diagonals are equal. And from rhombus as well, it takes two of its special characteristics. That is, here the diagonals are perpendicular and all sides are equal. So let's say if I write down all the characteristics and we'll figure out which of them is valid. Now, before we discuss the characteristics of these characteristics of quadrilateral, I just remember I forgot to tell you about a kite, which is again a special, is a quadrilateral, right? And it has some relation with rhombus. Okay, so if I name this as ABCD, here only like AD is equal to AB, right? So we can say that only two pairs of two pairs of adjacent sides are equal, not all pair. And other characteristic is number one, here the diagonals, only one diagonals get bisected. That means if I draw this kite here, then you should know that OD is equal to OB, right? And AU is not equal to OC. Further, they are perpendicular. Now let's begin with all the properties. I'll start from the bottom here. So the first is only one pair of opposite angles, only one pair of opposite angles are equal, right? So this is kite, right? Here, these angles, angle B is equal to angle D. So this is for kite. The next, as I said, we'll do from bottom. Only one diagonals gets bisected. So again, a kite. This is again a kite. Next is only one pair of adjacent sides are equal, kite again, right? This is kite. Fourth, only one pair of opposite sides are parallel. Now this is parallel, so this characteristics is for trapezium, right? This is formed in trapezium. So I should say this characteristics is only for trapezium. Next, diagonals bisect opposite angles. Diagonals bisect opposite angles. Well, this is diagonals bisect opposite angle is a rhombus, and since a square is a type of rhombus, is there in rhombus as well as square, right? So we'll say that this is true for rhombus and square. That is RH for rhombus and SQ for square. Next is all sides are equal. So all sides are equal again. There is in rhombus and in square. So it's again same, that is for rhombus and for square. Diagonals intersect at right angles. So diagonals you can figure out is intersecting here at right angle in rhombus, and if it is rhombus then it should be true for square as well, right? So what are these? These are kite, square and rhombus. Next is each angle is 90°. Each angle is 90°. So each angle is 90°. That's there in rectangle and in case of a square. So that is square and rectangle. Diagonals are equal. Next is diagonals are equal. Wait. I should have written at the bottom. This one, right? Now next is diagonals are equal. So diagonals are equal. It is there in rectangle, right? And since square is a type of rectangle, so that's true in rectangle and square. So this is square and rectangle. Moving above, adjacent angles are supplementary. Well, adjacent angles are supplementary in parallelogram, but you should know that these are special types of parallelogram, so they will also have these characteristics. So that means it will include all of these. That means is there in parallelogram and all other special types of parallelogram. That means square, rectangle, and rhombus. Diagonals bisect each other. Diagonals bisect each other. Since it is true for parallelogram, it will be true for all these three special types of parallelogram. Second last from bottom. Opposite pair of opposite angles are equal. So again, it's there in parallelogram, so it will be true for all the types of parallelogram. So it's true over all these. Next is both pair of opposite sides are parallel and equal. Yeah. So parallelogram again and all these special types of parallelogram. I think we did all types of parallelogram and their characteristic.